Good afternoon, friends. Welcome to today's session of materials management. Today's we'll be discussing the unit 8, that is spare parts management. We'll start with a hydroelectric project. You might have known about the KBK district of Odisha. KBK stands for Kalahandi, Balangir, and Koraput. These three were the underdeveloped districts of Odisha earlier, and it was famous for this farmers' suicide and all due to lack of irrigations and all. So in Bhavanipatna, that is in Kalahandi district, in 1999, the government has set up a hydroelectric project. The project name is Upper Indravati Hydroelectric Project. It is in Mukhiguda, Kalahandi district of Odisha. It has multi-purpose utility. The first one is irrigation. People think that hydropower plant means first is power generation. But here the major focus was on irrigation. It covers all parts of Kalahandi. And we have seen that after this project, the rice production of Kalahandi is increased by 5-folds. Next, it controls flood, Navaranpur, a nearby area of Hati River. Then it generates power. The capacity is 600 megawatt. It has 4 150 megawatt turbo generator sets. It comprises of 110 square kilometer reservoir, 4 dams, 8 dikes, together with associated channels, tunnels, shafts, and penstocks in the Koraput and Kalahandi districts of the state of Odisha. Here we have taken a news item. This is Odisha's Kalahandi district once caused the global embarrassment for India due to its high number of starvation deaths. Today stands tall with a 5-fold increase in its rice production since 1999. This 1999, this hydroelectric plant set up. The Agriculture Minister's recent crop data ranks Kalahandi among the top 25. This is among the top 25 producing districts of India, right? So this is the importance. And next about the hydroelectric plant, we'll see how the hydroelectric plant operates. The stock of water, this stock of water, that means water is stocked and we have potential energy. Then water from here, this side to this side, water flows. That means this potential energy is converted into kinetic energy. And it rotates the turbine. So here the kinetic energy of the water is converted into mechanical energy. Then generator, the mechanical energy is converted into electrical energy. So here we have stock of water is potential energy, flow of water is kinetic energy, turbine rotates mechanical energy, generator converts it to electrical energy. Let us talk about the generator, which is a major part. So here generators, there are 4 generators. And Fuji Electric Company, Japan, they have supplied this generator. So we'll talk about this generator. So as we have seen, that generator is one of the major components of this plant. So along the generator, that means when they purchase the generator from Japan, they buy 20%. They buy 20% of the spare parts. If in today's date, the cost of generator is 80 crores. So we have 4 into 80, that is 320 crores. This is the cost of generator. And they have a rule that 20% spare parts cost around 20%. That is 20% of this 320 is 64 crores. That means they are handling spare parts of 60 crores. And there are many spare parts. So let us take one, that is filter. So filter they changed in every 6 months. And cooler they changed in every 6 years. And starter is one of the component here. This is the starter. Starter is a durable product, and they have not changed this in the last 25 years. That means since inceptions they have not changed. So they have categorized these spare parts into these three. One is fast moving, that is the filters. Second is slow moving, that is the cooler. Immovable or non-moving, this is the starter. So filters means they changed every 6 months. Here cooler 6 years, and immovable it depends. It's a durable product. So here that means we are managing 64 crores of spare parts, right? So how we will manage this 64 crores? This is our spare parts management. And 64 crores is not a small amount. Then let us talking about spare parts. Spare parts is a part of a machine, engine, etc. that you can use to replace an old part which is damaged or broken. Generally, if you see in our two-wheeler or four-wheeler also, if there is some problem, we change the spare parts and all. Then about the purpose of the spare parts. A spare part, service part, repair part or replacement part is an interchangeable part that is kept in an inventory and used for the repair or refurbishment of defective equipment or units. Then the importance of spare parts management. The purpose is the right parts in the right quantity to the right place at the right time with the right level of quality and at the least total cost to the organizations. And the objective of spare parts management is to ensure the lowest overall cost. This is the lowest overall cost, lowest overall cost of spare parts possible without compromising availability. A high level of availability requires spare parts to be available or for the delivery time to be as short as possible. Next, coming to the introduction, spare parts management is crucial for maintaining the plants and equipment required for production and operations. An effective spare parts management ensures the continuous availability of assets for manufacturing without a drop in productivity levels. In spare parts management, there are two major issues. First one is stoppage of production due to non-availability of spares. Next is equipment operating at lower efficiency levels because of poor quality spare parts. So machines stop work, then the machine, so we have planned maintenance and then breakdown. So proper maintenance plan operations. This classification includes all the supplies a business needs for its production process that do not become part of the end product. So this is important. They do not become part of the end product. Rather, they help in production. MRO inventory, will see some examples. MRO inventory is often overlooked because it doesn't generate revenue, at least not directly. But as you will see, mismanaging MRO inventory can disrupt your supply chain and detrimental to your bottom line. MRO inventory might not be related to the core function of your business, but neglecting them leads to downtime, upset customers, and inefficient operations. For examples, your personal protective equipment, PPE equipment, like our gloves, masks, safety glasses, hats, hard hats, like helmets and earplugs. So this is coming under MRO, personal protective equipment. Cleaning supplies like your mops, brooms, brushes, and buckets. It is coming under cleaning supplies. Then office supplies is your notebook, pen, paper, batteries, staplers, folders, etc. And industrial equipment like valves, compressors, lubricants, motors, other spare parts. Technology and hardware related, there are computers, printers, scanners, papers, shredders, etc. Here we will see the issues and challenges of spare part management. We see the failure rate. Spare parts failure rate varies with machine's life cycle, nature of its use, and the extent of preventive maintenance. Failure patterns are typically represented as a bathtub curve shown in this figure. Please refer to this figure. This is our bathtub curve. Bathtub curve. This curve has three sections: early failure, constant or low failure, and wear out or high failure period in an equipment life cycle. Initial stage. Initial stage means this stage. This stage, initial stage. Here, just after installation is the initial stage. Here, the regions of failures are, it is either manufacturing defect because the products are new, either manufacturing defects or wrong installation, or initial incorrect action related to using the machine. Might be not trained employee, right? So machine generally does not fail. Situation is complex when machine falls suddenly with less unknown failures in the past. So you have complex situations. You don't know any information. You don't have any past data. So generally parts come under warranty because these are all new products. Then coming to constant performance stage. So here, this is the constant. So here failure rates are predictable with higher accuracy levels. Plant maintenance reduces breakdown. Last one is wear out. This is the decline stage, wear out phase. So individual components have higher failure rates because these are old spare parts, right? Time taken to repair, replace is higher. Necessary to hold inventory of all vital and essential parts irrespective of their value. Then we'll see some classifications of spare parts. The first one is VED. V stands for vital, E for essential, and D for desirable. Suppose in case of healthcare industry, oxygen is a vital product. It is the most important product. Patient has suppose suffered some serious illness, so you require oxygen, life support system. So oxygen is coming under vital. Then your healthcare equipments and all, this will come under essential. Then your bed, cabinets, etc. These are come under desirable. So let us see what is vital, essential, and desirable. Vital. A component without which a machine or equipment cannot function. Right? So this is vital. Vital spare parts replace the vital components and cannot be repaired or temporarily made to work with interim support. Vital components are necessary to ensure uninterrupted production. So for example, breakdown of a shaft of a machine will cause the production halt and needs immediate replacement. If you see this figure, this this figure is about your hydroelectric plant. So you have turbine and generator. So this shaft, suppose this shaft has some problem, means so you have to replace this shaft. So this shaft is a vital product. Then essentials. Their breakdown can cause stoppages but can be repaired without making replacement. In case where repairs do not yield the desired result, the machine operates suboptimally. That means with less efficiency. But the machine doesn't stop here. And the repaired part may be replaced with new ones. In such cases, the production unit gets some time to buy a new spares if the same is not available in the stock. The example is a faulty gearbox of a machine. So it can be repaired and reconditioned for further use. Suppose it is a shift duty, after 2 hours they detected. It can run for another six hours, but you have some less productivity. You have some inconvenience, but the production won't stop. Next is desirable. Desirable ones without which the operation can continue but cause inconvenience to the operator and processes, leading to delays and low performance. For example, a broken machine handle. This is a broken machine handle. Broken machine handle will not cause a stoppage of operations but cause inconvenience till it replaced. So last one for healthcare we have seen. Vital is oxygen. Essential is critical health care equipments. Desirable is bed, cabinet, etc. Next is SDE analysis. S stands for scarce, D for difficult, E for easily available. Certain items are scarce, sources are limited, and demand exceeds supply. You have more demand than supply. For example, rare earth elements such as lithium and platinum required in making components are scarcely available and affect the supply of spares. Scarcity can also arise from unusual events such as COVID pandemic, spare parts management, and Russia-Ukraine war. These two events lead to shortage of semiconductors, affecting the supply chain of computer chips required in many equipment and products such as automobiles. If you remember in the COVID situations, Maruti plant, both the Maruti plants in two locations, they have stopped due to the non-availability of these semiconductors. So that is scarce item. Next is difficult items. So here the items are unavailable locally and may have to be produced from distant sources, leading to a higher lead time for supply. Items procured from overseas take a long time to get customs and other statutory clearance. Some items are difficult to handle and may require special handlings, such as odd-shaped or over-dimensional materials and all. Machines, turbines, etc. Then easily available items. These items do not pose challenges as they are readily available. Easily available items may become difficult to get when OEMs stop operations. For example, if you see Ford Motors withdraw manufacturing from India in 2021. So these spare parts of Ford Motors are difficult nowadays. Next is FSN, fast moving, slow moving, non-moving. Fast moving is certain items are fast moving and do not have the problem of obsolescence. In such cases, availability is challenging if these are scarce or difficult to obtain. If we remember first, we have discussed the filters. They change the filters in Mukhiguda, in power plant, Hydel power plant. They change the filters in every 6 months. These filters. So the filter is coming under this fast moving. Next, slow moving. Cooler they have changed in every 6 years. So it is coming under slow moving items. So the failure rates of some components are low and the spare parts inventory is used less frequently, getting obsolete. So here the challenge arises if a slow moving item is vital and has a high cost. Non-moving items, the rate. So here the non-moving item is a starter because for the last 25 years they have not changed. So here fast moving, highest replenishment rate occupies 20% of inventory. Slow moving, lowest replenishment rate occupies 35% of inventory, and non moving, also known as dead stock, and occupies 50% of the inventory. Next is high valued, medium valued, and low value. Such high value means such parts stored for longer time results in higher holding and opportunity cost as capital is blocked. At the same time, if the spares is vital, high value items, it poses a greater challenge. A contract with the spare suppliers for vendor managed inventory could help the non-blocking of capital and be available when needed. VMI, vendor managed inventory, means you ask your vendor or supplier, so he will, that fellow, the supplier, will keep the material in your premises, but you don't have to pay. You will only pay when you use it. That means the materials is in your premises, but it belongs to supplier. So when you need the material urgently, you take the items and you pay the bill. So that is VMI. Next is medium valued items. So spares of medium value pose a challenge when they are slow moving but are either vital, scarce, or both. Then low valued item. These spares, when stored, have low holding and opportunity cost, but care needs to be taken when they are non-moving, result in obsolescence. Next, coming to the most important part of this session, this is our ABC analysis. ABC. Some people they call it as always better control. ABC analysis. ABC approaches, it categorize inventory into three groups: A, B, and C. A items accounts for 20% of the total inventory volume. 20% of the total inventory volume, but have a high consumption value around 80% of the entire inventory cost. That means these are the vital part. Class A items, 20% of the total inventory volume. That means if you are managing 20% of the volume, 20% of the material, you are managing 80% of the inventory cost. So A items are vital. Then B items. B items, here you have 30% of the total inventory volume, but worth 50% of the total inventory cost. C items, these are trivial items, 50% of the total inventory volume, but worth around 5% of the total inventory expenses. So it is also known as vital few and trivial many. That means A items are vital items. If you see this here, this is cumulative percentage of unit and cumulative percentage of total inventory value. So here you have 20% of inventory, it constitutes 80% of the cost. Right? So B 30% is 30% is 15% is cost, and C 50% is 5% is cost. Actually, it comes from Pareto's law. Pareto v. Pareto. Actually, he was born in France and was an Italian scientist, a civil engineer, economist. He died in Switzerland. This Pareto principle is known as 80 by 20 rule. 80 by 20 rule. The law of vital few. It states that many outcomes, roughly 80% of consequences, come from 20% cause. Let us take the example of fundraising. You take this example of fundraising. Suppose there is 1 lakh. You have raised 1 lakh. So 20% is that suppose 10 people have contributed, two significant people, they have contributed 80%, 80,000, and rest 80% of people, that means 8 people, they have contributed this 20,000. So these are vital few, trivial many. That means if you refer to this figure, your effort is 20% here. According to the Pareto principle, your effort is 20%, but result is 80%. So in case of a steel plant, if we classify the ABC item, the A item is coming out iron ore, coal, etc. Because these are the main vital products and valuable products. So iron ore, coal, they are coming under A item. B are ferroalloys, refractory, etc. are coming under B. Other consumables and spares are coming under C, ABC. Let us take an example. So here we assume that A means 20% of the item, they constitutes 80% of the value. B, 30% of the item, 15% of value. C, 50% of the item, 5% of value. So here, this is the procedure. This is the procedure. Determine the annual uses of each item. So here, first is compute the value in Indian national rupees of the annual usage of each item. Suppose there are 15 items, you calculate the annual consumption. Then arrange the annual consumption in descending order, highest to lowest. Then compute the percentage of annual uses in units. Then determine the percentage annual uses in rupees. Then determine class A, B, and C in terms of percentage annual rupees. So here we'll take an example. This example, a company manufactures a line of 10 items. Right? Their usage and unit cost are shown in the following table, along with the rupees usage. The latter is obtained by multiplying the unit usage by the unit cost. So we have to calculate, number one, we have to calculate the annual rupees usage of each item, list the items according to the annual rupees, then calculate the cumulative annual rupees usage and cumulative percentage of item, then group the item into A, B, and C classifications. So let us see. So first one is A. We'll calculate the annual INR usage of each item. So these are the part number 1 to 10, right? So unit usage, that means part number A, unit usage in a year is 1,100 and unit cost is 2. So annual rupees usage is this 1,100 into 2, it comes 2,200. So part number 2, 600 unit usage per unit you have rupees 40, so 600 into 40 you have 24,000. So likewise we have calculated the annual rupees usage. So total units is 5,510 and total rupees is Indian rupees is 38,250. So this is our last table. Now what we do, we have calculated this. We have calculated this annual INR usage. Now we arrange this in descending order. That means what is the highest value? This is the highest value. 24,000 is the highest value. It belongs to part number 2. So first, part number 2, annual usage is 24,000, right? Then you have, after 24,000, you have this 6,000, part number 5. So here we have part number 5, 6,000, like this, right? So we have arranged in descending order, right? Here now we take the cumulative rupees. So first, part number 2, annual usage is 24,000. So total is 24,000. Next, 6,000. So cumulative is this 24,000 plus 6,000 comes 30,000. Next, this 30,000 plus 3,000 is 33,000. 33,000 plus 2,200, 35,200. So last value comes 38,250, which is also same as this 38,250. Okay. Then we'll take the cumulative percentage. Suppose part number 2 cumulative is 24,000. So total is 38,000. So this is 62.75%. Next, up to 5, this is 30,000. So 30,000 in percentage is 78,000. Now 86 percentage, 92 percentage, etc. Now, what is A class item? Classification A items is, it constitutes 20% of the materials and 80% of the value. So if you see 80% of value, this is coming 78.43, that means 78.5. So approximately we will take this, right? So these two will take as A category item. That means number A category item is number 2 and 5. This will come under A category item. Next, B is 15%. So 80 plus 15 is 95%. So 95 means 95 is here, 95.42. Right? So we'll take up to this, right? So 8, 1 and 4 are B item. So 8, 1 and 4 are B item. Rest is C category item. So we have categorized these 2 and 5 are A, 8, 1 and 4 are B, and rest are C. 10, 9, 3, 6, 7 are C. Now we can plot a graph. Right? Here we take in x-axis percentage of items and in y-axis percentage of value. Next is inventory level. The volume of inventory is to be maintained depends on the following factors. One is significance, whether the class is vital or essential. Then the frequency of usage, class is fast moving, slow moving or non-moving. Then availability, scarce product or desirable product. Then lead time to supply. The last one is uncertainty or deviations in supply time, supplier and supply chain reliability. So in case of organizations deciding to maintain the inventory, the above factors are considered for optimal stock. This is important. Optimal stock. Suppose the demand per annum is constant with no lead time. That means instantaneous replacement with no shortages, back orders, and quantity discounts allowed. In that case, the following EOQ, economic order quantity, or this EOQ model can be derived. We'll see in the next one. What is this EOQ? What is this EOQ? EOQ means mathematically devised for arriving at the purchase quantity of an item that will minimize the cost of equation. Here we consider there are mainly two costs. We assume one is your holding cost, another is your ordering cost. What is ordering cost? Suppose you are ordering an item. The cost associated with ordering a product. Suppose some people are involved in making an order, then you give that order in a courier, then they supply the material. You have to pay the transportation cost and you inspect the monies and all. So it constitutes the total ordering cost. That means cost per order. Next is the holding cost. That means material comes, then you hold the item in the inventory. That cost is your storage cost or holding cost. So here our total cost is ordering cost plus holding cost. Now we want to minimize the total cost. Our objective is to minimize the total cost, because inventory management means we are keeping your working capital. So this is the EOQ model. In x-axis you have quantities. In x-axis you have quantities order. In y-axis you have annual cost. Let us take about ordering cost. Suppose you are ordering less quantity. We are talking about annual cost. If we suppose in a house, suppose we require 5 kg. Suppose annual requirement is 60 kg. If we order 1 kg of sugar, then we have 60 orders, right? 60 orders into ordering cost, so ordering cost is high, right? If we order 2, then 60 by 2, we have to give 30 orders, so ordering cost decreases. So this is the graph. So as quantity increases, your annual ordering cost decreases. But what about the holding cost? If you are ordering 1 kg, you are storing 1 kg, and storing 1 kg, storing 5 kg, you need a larger vessel, you need larger security, you need larger space and all. So with increase in quantity, order quantity, your holding cost increases. So you increase order quantity, the ordering cost decreases, but carrying cost or holding cost increases. So we add this ordering and holding cost, we get the total cost, right? So total cost, it has a minimal point, this point. So this point corresponds to the quantity is your EOQ. That means this is your economic order quantity. That means if you purchase less than EOQ, then your ordering cost, then your total cost increases. If you are ordering higher than EOQ also, your total cost increases. So this If you order at this point, your total cost is minimum. Next, we will calculate the EOQ. If the total demand is D, total demand means our total annual demand is D. Q is the order placed at a given time. Then total number of orders is D divided by Q. D is the annual demand divided by Q. Q is the quantity order. Suppose for our sugar, suppose D is 60 kg and you are ordering per order 5 kg. So 60 divided by 5 is 12. Number of orders is 12. Suppose cost per order is CO is cost per order. So total ordering cost is number of orders into cost per order. So this is your total ordering cost. Similarly, carrying cost or holding cost, you are ordering Q, right? So at a time, so Q is the maximum, 0 is the minimum. Suppose here we don't keep any safety stock. So Q is maximum, 0 is minimum. So on an average, Q by 2 is the average item inventory. So this average inventory into CH. CH is the holding cost per unit. So this is our total holding cost. So in EOQ, we have seen here in EOQ, our ordering cost is same as carrying cost. So at EOQ, our ordering cost is equal to carrying cost. So equating the ordering cost with holding cost, we get D by Q into C0, which is this ordering cost, is equal to Q by 2 into CH, is this. So what is this Q? Q is root over of 2 D CO. CO is ordering cost divided by CH. CH is carrying cost. So D is the annual demand, CO is the ordering cost, CH is the carrying cost. We'll see an example. Just we take an example. Suppose holding cost are rupees 35 per unit per year. This is the holding cost, 35 per unit per year. This is the CH. And the ordering cost is rupees 120 per order, CO. And the sales are relatively constant at 300 per month. So 300 per month, that means annual is 300 into 12. So we have to calculate the EOQ and annual inventory cost. So what is the demand? Monthly it is 300. So yearly 300 into 2 is 3,600 is the demand. Ordering cost is 120. Ordering cost is 120 per order. Holding cost is rupees 35 unit per year. So what is the equation? EOQ is 2 into demand. Demand is annual demand into ordering cost divided by holding cost. So 2 into demand is annual demand is 3,600 into 120 is this cost per order divided by 35 is the holding cost, which is coming 157.12. We can take 158, add round up. Then total cost, we'll take ordering cost plus carrying cost. So ordering cost is 3,600 into 120 divided by 157.15 is your EOQ plus this 157.12 into 35 by 2, which is coming around 5,500 roughly. So that means if you, what is the significance of EOQ? That means if you give order at EOQ level, then your total cost will be minimized. Then your reorder level. Reorder level is expressed as a summation of average consumption during the lead time, LC, and safety stock says lead time is equal to lead time and QC, average consumption per day. See, you see this curve, right? This is our maximum level, right? Suppose here we keep some safety stock. right? So this is the demand pattern. X-axis you have time, days, y-axis you have stock level. Suppose here order comes, material comes. So this is the Q, so it increases. This is the consumption rate. That means as time increases, this decreases, right? So this level is your reorder level. That means when the material reaches this point, you place an order. Say for example, suppose our EOQ is 5 kg in our house for sugar. Our EOQ is 5 kg. This is 5 kg, right? Here, our mother has calculated that this is 1 kg. Reorder level is 1 kg. That means suppose this is a transparent jar, glass jar. When this is the demand consumption rate, as time increases, days increases, this stock decreases. When it reaches 1 kg, this reorder level, our mother place another order, right? This is the lead time. Suppose in 2 days we receive the material, so again it increases to this, and this is the safety stock. We are keeping some safety stock because due to some stock out and all. So safety stock takes care of uncertainty in lead time. Suppose there are some, due to some unavoidable circumstances, lead time increases. So safety stocks, we can use the safety stocks at that level. Then reorder level. So we use the reorder level formula. So calculate reorder level with proper formula using your average demand, lead time, and safety stock. The formula is as follows: reorder level formula is equal to average demand into lead time. This average demand is the consumption rate into this lead time. This is the formula in case safety stock is kept by the company. So reorder level is equal to average demand into lead time plus safety stock. So here is the reorder point. That means suppose this yellow line is the reorder point. That means this is the demand consumption rate. So consumption rate decreases when time increases. When it reaches this, you place an order. You place an order for how much? You place an order for EOQ, economic order quantity. So this is the lead time. When it reaches, again it increases, right? So this is your formula. Next is the XYZ analysis. It is like ABC analysis, but it varies. An XYZ analysis divides items into 3 categories: X, Y, and Z. X items have the lowest demand variability, right? The variability of demand is lowest. Y items have a moderate amount of demand variability, usually becomes because of a known factor. Z items have highest demand variability and therefore the hardest to forecast. Now we'll combining XYZ with ABC analysis can reveal more details. So here we'll take ABC XYZ, this matrix. So here in AX matrix, right, we have high volume, smooth demand rate, because X means lowest demand variability. So demand is smooth. So high volume and smooth rate. So here in AX, we can use just in time because you know the demand pattern and these are of high value. You don't want to, why we keep much materials, because we know the demand pattern and all. So we can apply JIT just in time here. Right? Then if you take this CZ items, right? Here C are low volume and Z are random. That means the Z is highest demand variability. So volume is low volume and demand is random demand. So here we can take high buffer because safety is fast. You don't know what is your demand and all, and but they are of low value. So here we can keep high buffer. So this is the XYZ and ABC. Suppose BY this. So here you have medium volume seasonal demand. So here it is manually adjusted buffer for seasonality. This is used for seasonal product. Next is forecasting of spare parts requirement. Prognostic maintenance aims at identifying the present and future conditions of the components of a machine and predicting its residual life of failure. So this prediction result is used to arrange spare parts and replace the items before failure. So there are some methods. One is data-driven method. So here machine learning techniques such as neural networks are used for predicting residual useful life. So this is a data-driven approach where data on the component's condition, the cause is the component's condition, using sensors and machine's performance, the effect are collected and analyzed using machine level algorithm. Right? So this is the RUL estimation. Next is model-based method. So here the failure patterns are modeled using nonlinear and spatial models, and their variations such as non-heterogeneous Poisson processes NHPP are used. Next is hybrid methods. So data-driven methods are treated as black box approach and may give less accuracy result due to a over or underfitting data. Model-based methods rely on fewer data and are helpful, but may be complex to formulate and solve it. So current approach includes hybrid methods that integrate both data-driven and model-based approach for your greater accuracy and prediction. So last one is our spare parts life cycle. So here we have, it comprises of 6 stages. First is requirement identification. Next is specification of spares. Next is inventory level to be maintained, reorder level. Next, quantity to be ordered, usage and disposal. So very fast is requirement of identification. So as we have seen this bathtub analysis, we do the bathtub analysis. So we calculate the mean time between failure and mean time to repair. This is the requirement of identification. Next is specifications. So we know that we require this materials. Next is specifications. That means we need, suppose we have detected these items, the purchase department has to procure these items correctly. Incorrect material may lead to poor performance purchase from OEM. So these specifications, codification is important. Our next class will see codification of item. That means standardization. Next is reorder level. For stable inventory, as we have discussed, vendor managed inventory. That means we ask our vendor to keep the items in our premises. When we use the product, we pay the bill. So it reduces our cost. So reorder level can be reduced if you approach this BMI concept. Then for quantity order, as we have discussed, we will go for EOQ. If we go for economic order quantity, our total cost will reduce. We can have P system or Q system. Q system is fixed quantity. P is fixed period. So here in Q system, stock on hand reaches to reorder point. Here in P system, based on fixed review period. That means on every 15 days or every 30 days, we see the stock. If it reaches the reorder level, you go for another order. But here in queue systems, whenever material dispatches, you see the order level. If it reaches safety stock, you order another. So last one is the usage and last one is the disposal. Because disposal also is an important point, like your battery, your automobile batteries, inverter battery. Recycling is the techniques of reusing and reprocessing batteries to minimize the number of batteries disposal. Because we have several toxic compounds and heavy metals are there in the battery. So there are some laws. So the summaries, we have discussed the importance of spare parts management. What are because for smooth function of the organizations, all machines has to run efficiently and effectively. So for that, you need smooth management of spare parts. And also, we have to minimize the cost. And we see the bathtub machine life cycle. And spares we have seen this VED analysis, HML analysis, ABC analysis, XYZ analysis, etc. Then we have discussed EOQ model, economic order model, and lastly, the spare parts life cycle. Thank you. Thank you.